Hi class, we're back with lesson 5, unit 5, lesson 5, part A, and we're talking about, again, the theme of personal finance, and in this case we're going to be talking about how to display data in a table. So it says to look back at the graphs you used in lesson 4, part D, where they show the Hispanic and non-Hispanic U.S. population illustrated with several types of graph. It says once the graph has been made, you've lost the original data values, which is kind of important with a lot of graphs. That the graphs are nice because they give you a picture of the data, but once things are in a graph, oftentimes you don't have the exact data anymore. Either they're grouped together, or when you look at the graph, you can't get the exact number that you could get, say if it was in a table. In the table we can get the exact value, but once it's placed on the graph we can only see the approximate value. Like you couldn't tell the difference, say, between 1,446 and 1,452. They would be too close on the graph to be able to tell the difference between the two. So depending on the data. And so one way to put data from a table into a pictorial form without losing the original data values is to use what's called a stem and leaf plot. What's nice about a stem and leaf plot is it gives you sort of a picture of the data, but at the same time it holds all those original data values. So we're going to look at some information on the fuel economy. This says it's collected by the U.S. Department of Energy, and fuel economy is just a fancy word for your gas mileage, how many miles per gallon you use, or a vehicle uses. So in this case, we have the 2013 Chevy passenger cars, pickups, and SUVs, and their highway miles per gallon. And this is only for gas-powered vehicles, of course. Anything that's not just a standard gas-powered vehicle would not really fit with this other data. So how do we read this? Well, if you look at this key right here, it says that if you have a 1 and a slash and then a 5, that means 15 miles per gallon. So on here, you notice over here, this is what's called, again, a stem and leaf plot. These are the stems in the data, and this 1 doesn't actually mean 1, it actually means 10. The 2 means 20, the 3 means 30, and the 4 means 40. So when you look at this, 1, 5 means 15, but also this 6 here means that in the original data there was a 16, and this 8 means there was an 18. And another 18, and another 18, and another 18. So in the data there was 115, 116, 4 18s, 2 19s. In this case, that means that there was one Chevy passenger car, pickup, or SUV that got 15 miles per gallon. There was one that got 16 miles per gallon. There were 4 that got 18 miles per gallon. And there were 2 that got 19 miles per gallon. So then going down to this next stem, this is 20, and so 20 means 20, 21 means 21. So there were several vehicles that had 21 miles per gallon. There were 2 vehicles that had 22 miles per gallon. Another several, not as many, but it looks like 7 vehicles that had 23 miles per gallon. What is that? 1, 2, 3. Another 7 that got 24 miles per gallon. 1 that got 25, 1 that got 26, 1 that got 27. But the biggest thing here is to realize that this 2 followed by this row of numbers means these are all the 20s. So this 9 right here doesn't just mean 9, it means 29 because it's in that row of 20s. And then I'll just kind of go to the end here and cut to the chase. So down here, the one with the highest gas mileage would have a gas mileage or miles per hour of 42 miles per gallon. So it says find the key. So we looked at the key already. The stems represent what place value? So these are the stems. So the stems represented the tens. Okay, so it represented 10s, 20s, 30s, and 40s. So it was like the tens place. Each leaf represents which place value? So these would be the ones. So 1, 5 means a 10 plus 5, a 10 plus 8. So the leaves, or the leaves, I should say, are the ones place. So going down a little bit here, it asks next, compare the number of 21 entries to the number of entries in the teens. And so if we go up here, these are the 21s. The 21s start here. We talked about how there's several of them. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 that are simply just a 21. And then it has to compare that to all the ones that are in the teens. So that means something that starts with a 1. There's no 11s or 12s or 10s, so I guess they can call this the teens. There could be ones in this row that weren't teens. But these are all 15, 16, 18, 19. So if we look at these, there are 1, 2, 3, 4, 5, 6, 7, 8. So in this case, we could say, it says to use your good writing principles, so I'll put this up here. There are 9 So there are 9 vehicles with a gas mileage, or miles per gallon, of 21 in the 2013 Chevy vehicles. And only 8 with miles per gallon of 15 to 19 miles per gallon. So when they say the good writing principles, they're just saying, don't just say there are more in the 20s or there's more 21s than there are teens. You have to specify so somebody reads this, they actually can understand what you're talking about. So we specify things like there are 9 vehicles with a miles per gallon of 21. Specify what the number represents. Specify what you're talking about, the 2013 Chevy vehicles. And again, rather than saying in the teens, I said from 15 to 19, so that you could see exactly where we're talking about. Different ways you could write this, but the idea is to get some detail in there and not just be real cryptic with what you're saying. So now it asks, how many 2013 gas-powered Chevy vehicles get more than 25 miles per gallon? Now, I can tell you that the mistake that I've seen people make in the past is they go up here and they find the 25 and they want to get more than 25, and so they'll say 1, 2, 3, 4, 5, 6, 7. Okay, so there's 7 past the 5 in this row. But what some students will do sometimes is they'll forget to realize that, hey, anything that's in the 30s and 40s is also over 25. Also, we don't want to include 25 itself because it says more than, not more than or equal to. So we're going to just start with the 26, and that would be 1, 2, 3, 4, 5, 6, 7, plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So there were, in this row, there were 22 total. And in this row, there were 7 that were past that. And then there's 3. So there's 7, 22, and 3. So that makes a total of 32. Hopefully I counted right. If I miscounted, hopefully you understand what I'm saying anyway. That there are 32 gas-powered Chevy vehicles that get more than 25 miles per gallon. And that's everywhere from 26 up to 42. Okay, and then the last question that's asked here, or says here, is that we're to take turns in your group identifying interesting features in the plot. One thing they give for example is there's no 2013 gas-powered Chevys that get less than 15 miles per gallon. And we're supposed to look for some big ideas rather than individual things. Record at least 2 observations. So I'll just go back here and I'll mention some things that groups have said or that we've noticed in class before. So if you go back up to the graph and you look for some big picture ideas, first of all, I kind of forgot to mention that when you're looking at this, one of the things that's nice about this is even though it keeps all the data points, we still get kind of a picture. Like you can readily see which group of 10s has the most and the least. So one thing you could say is a big picture idea, or a big idea, is that there's many more in the 20s, many more vehicles in the 20s for miles per gallon than there is in the other categories. That there's very few that get 40 or more, and in fact the highest is 42. So that's what they mean by some big ideas. There's many more in the 20s than there are in any other category. The next biggest is the 30s. No vehicle gets over 42. No vehicle gets under 15. There's very few in the 40s. There's not very many more that are in the teens. You could say something like most vehicles get somewhere from 20 to 39 miles per gallon. You know, even though there's one at 15 and there's a couple, you know, 3 at 4 in the 40s, most all of the vehicles get somewhere in the 20s or 30s. So when they're talking about these big ideas, that's the type of thing that they're looking for. So now for items 5 through 7, we have another stem and leaf plot that we're looking for, and this is a different type of stem and leaf plot. This is what's called a back-to-back stem and leaf plot. Now, before, we knew that this stem represented the tens place, and then we know that these numbers represent the ones. However, this has another set of values to the left of the stem. It's very interesting to have these back-to-back stem to leaf plots in order to compare data, but the left side is a little bit confusing to read, and we would never make a only left-sided stem and leaf plot. You either do a right-sided or a back-to-back. So let's just kind of look at some of these. It says this is for two different classes. They're history classes that took a test. And so this right here means that there's a student in the 11 a.m. class that got a 16 on their test. There's another one that got a 18, another that got a 19. No one in this class got in the 20s. There's someone that got a 30, a 35, and a 39, and so on, up to the highest score in the 11 a.m. class was an 83. If we look on this side, we still want the values, the smaller values, to be closest to the stem. But in order to do that, we have to go backwards. So everything on the left side of this back-to-back stem and leaf is read backwards. So even though it's nice for comparison, the left side gets a little confusing. So this means that somebody in the 8 a.m. class got a 15 on their test. Someone else got a 37. Someone else got a 47. There were 3 students in the 50s, 51, 52, 54, and so on, up to the highest score in the 8 a.m. class, and in fact the highest score overall was a 96. So when you're reading these, a couple points to remember. The smaller values, 80 would be here closer to the stem than 89, go into the stem, and then when you read the left side, you have to read the stem and then the leaf, which means you're reading to the left instead of to the right. You're reading kind of backwards. So now it says how many students scored in the 90s in the 8 a.m. class. So in the 8 a.m. class, we had a 90, another 90, a 91, a 92, a 94, a 95, 96. So how many is that? 1, 2, 3, 4, 5, 6, 7. So there were 7 that scored in the 90s in the 8 a.m. class. What about the 11 a.m. class? Well, that's easy to count because there weren't any. So there were none of the students in the 11 a.m. class scored in the 90s. It says, once again, take some turns in your group identifying interesting features in the plot. Look for big ideas rather than individual entries. Record at least 2 observations from your group. So I want to point out some features that you might look at. And before I say this, you might even pause the video for a second and try to come up with some of your own ideas and see if you come up with some of the ones that I come up with. So if you want to do that, go ahead and pause right now and come up with some of your own big ideas. So some of the things that I would point out is, first of all, I'm used to and have seen a lot of stem and leaf plots, and when I look at this, it's immediately obvious that this 8 a.m. class did much better than the 11 a.m. class. You notice there's much more of the data is in this area than for this class. This class is kind of centered, or the middle of the class looks like it's around in the 50s and the 40s, whereas this class, the middle of the class is somewhere in the upper 80s to lower, or upper 70s to lower 80s probably. So this is much heavier with what we would consider good scores than the 11 a.m. class. Also, there's a lot more students in the 8 a.m. class. This just visually, I'm not even counting, but just visually I can see there's a lot more values over here than there are over here. So this class did a lot better than the 11 a.m. class. There's more students in the 8 a.m. class than there are in the 11 a.m. class. However, the lowest score was in the 8 a.m. class. Even though overall they did better, the actual lowest score was in the 8 a.m. class. And the highest score was in the 8 a.m. class. If you look at this, you know, if you consider 60s as passing, it looks like over half the 11 a.m. class failed. Over here, if you look at 60s, again, as passing, think of that as a D. Just FYI, in this class, since it's a developmental class, you have to have a 70 or above because you have to have a C or better. I can't give out a D, so I don't want to mislead anyone. But in most college classes, you do get credit for a D, even though it's not a good grade. So here you've got from 63 up to 96. That's definitely way more than half of the class that passed. Whereas here you've got more than half of the class that failed. So something's going much better in this 8 a.m. class than this 11 a.m. class. They, of course, don't give us any information on that. We can conjecture. We could say, well, maybe they're not coming to class. Maybe the professor doesn't like this class and gave them a harder test. I would hope not. But something happened between these two classes. So those are some observations. There are, in the 8 a.m. class, the most scores were in the 80s. The next most scores was in the 70s. No one in either class scored below a 15. No one in either class scored 100. No one in the 11 a.m. class scored in the 90s. Very few scored in the 80s. So all these things that I'm saying are these big ideas. It said record at least 2 observations, so you wouldn't be expected to get all those things, just a couple things. So now it says to list the errors you see in this stem and leaf plot. So there's some things that are wrong in the way that they've plotted these two sets of English scores from the 9 a.m. class and the 10 a.m. class. So what are some things? Again, take a minute to look at it yourself and see if you can come up with them. Maybe even pause the video for a second. But some of the things that I'm noticing, notice here it has a 3 and then a 5 and then a 7, 8, 9. They don't have a 4 and they don't have a 6. So when they make this stem, they really should, if 3 is the smallest and 9 is the biggest, everything in between should be filled in. So there should be a 4, 5, 6, 7, and an 8. Okay, so once you start with a tens place, you have to fill in all the tens place. Now, it doesn't look like there was anybody that was in the 40s or anyone that's in the 60s, but then you just leave that blank. You'll notice they did that up here. There was no one in the 20s. They still have a row there for the 20s. They just don't have it filled in. That way it's not deceptive. You can see that there was no 20s. You're not thinking, oh, it went right from the 10s to the 30s, and you could see it. So they should have put a 40s and a 60s. You don't actually have to go below the 30s if there's nothing below that. It wouldn't be inappropriate to put a 1 and a 0, I'm sorry, a 1 and a 2 in there and to leave them blank, but you don't need them. You only need to start with the smallest and go to the biggest. Also, some things that they did that are incorrect. This would be what's called an unordered stem and leaf plot, and typically we like to have an ordered stem and leaf plot. So you notice here they have 30 and then 39 and then 35. Typically we like to have them ordered, so the 5 should go first and then the 9. Same thing here. They've got 57 before 55. So we'd like these smaller values in towards the stem. And then over here, the same thing. They are, actually they don't have them out of order. They have them in order over here. They just have them completely backwards. So instead of the 51 being closest to the stem, they have the 54. So they go from smallest to biggest this way, where it should go smallest to biggest this way. So the 1 should be here and the 4 should be here. And then here the 0s should be over by the 7 and the 9s should be out further. So this is completely unordered and this one's ordered backwards. And then we're missing 2 values here in the stem. Okay, so now we're ready for Lesson 5, Part B. And we're still talking about personal finance, but now we're talking about what are known as relative frequency tables. Remember that relative means in comparison to, before it was relative change, it was comparison to where we started. Now with a relative frequency table, it's a comparison to the total. So relative frequency is a way of comparing what we have to the total number of values. So if we look at this, it says highway miles per gallon for 2013 gas-powered cars, but it specifies that these are mini compacts. So this isn't all the Chevy cars like we had before. It's actually all the different brands, but only the mini compacts, so the smaller cars. The U.S. government tracks gas mileage by the size of the car. This gives that gas mileage for those 2013 mini compacts. What information can you gain from a very quick glance at the table? Well, again, we're looking for some kind of big ideas. We're not necessarily looking for specifics, but some big ideas that we might notice is that there's a lot of 20s. You can see that. There's a few 30s, a few teens, but it looks like it's mostly 20s. These are not in order. At first glance, it kind of feels like they are because you see these 19s and then you see these 30s up here, but if you look, these aren't in order. Not in columns or rows. 19, 22, 26, 26, then back to 19. Or if you go this way, 19, 19, 34, 19. They're not in any order. If we wanted to make a stem and leaf plot of these data, what's the first thing that we would have to do? Well, we would have to make the stems, or the stem, and then we'd have to put the leaves. This would be kind of a real long stem and leaf plot, not very tall. So if we were going to make a stem and leaf plot out of this, there we go. We'd have to do 1, 2, 3. This is number 2. Problems. There we go. And then we'd have to start going through here, and we'd have a 19, another 19, and we'd have to do this and with all the data, and then we'd have to go back and reorganize it in order. So 34, another 19, another 34, etc. Okay? So the first thing we'd have to do, though, is make that stem. Another type of table known as a frequency distribution or frequency table, so not relative frequency yet, just frequency, helps organize the data into more useful forms. So the stem and leaf plot is great, but it gets a little cumbersome when there's a lot of data or when the data is not very spread out. So frequency basically just means how often. If somebody says, how frequent do you go to the grocery store? You might say, I go to the grocery store once a week. I go to the grocery store every other day. It means how often. So in this case, it's how often it occurs. So what we're going to do is we're going to go down here and we're going to tally up. They've given us some ranges. They've split it up, 18 to 20, 21 to 23, and so on. And we're supposed to tally how many are in each group. So they've started here with 19 is in the 18 to 20 group. The other 19, or the next 19, is another one in this group. The 34 is here. And I'm going to go through and do this for all of them. So we now have, in this next one, we have another 19. We have another 34. And you just make what's known as a tally, which is just a mark. And then we have yet another 34. In fact, we have 3 of them. So total, we should have 1, 2, 3, 4 34s so far. So there's my 34. And then right after that 34, I have a 35, which is in the same category. Typically with tally marks, once we get to 5, we make a cross over it, so that's a group of 5. Then we'd go to the 27. Oops, that's in the wrong spot. Hold on a second. So the 27 should be here, and then the 28, and then another 27, and another 28, and another 27. So I'm going to spare you watching me do that for the entire thing, and I'm going to fill it in, and then I'll start recording again. Okay, so now I've gone through the entire table and marked all the data into the correct range with a tally mark. And then frequency means just to take these tally marks and write down the number. So for this first one, we had 3 tallies, so there's a frequency of 3. So there were 3 vehicles that were from 18 to 20, so either 18, 19, or 20. Again, you notice that once it's in here, we've kind of lost the original data because I don't know if it was an 18, 19, or 20. I just know it was somewhere in there. Here, if I didn't have this information, all I know is that there's 4 vehicles in that range. I don't know exactly what they were. I don't know if it was 4 21s, a 21, 2 22s, and a 23. If I didn't have this original data, I would only know there were 4 in that category. There were 14 here. There were 5, 10, 13 here. 2 here. 5, 10, 13 here. And then 3 in that highest category. Okay, so now I've got questions 5 and 6 here. Sorry they're out of order, but I didn't want to redo this table. So it says the range column represents the bins that hold the data values. In this case, the bins are in increments of 3. So again, we have 18, 19, 20. That's what they mean by 3. I know if you take 20 and you subtract 18, you only get 2. But we're talking about what values are in here. So the values that are in here are 18, 19, and 20. 21, 22, and 23 would be in here. 24, 25, 26. So there's 3 values that would get placed in each of these ranges. The frequency represents the number of data values in each bin. So this frequency bin goes from 3 down through we lost some data here. I'm not sure how that happened. Let me try that again. So that should have been 13 and this was 3. So the frequency table tells you how many data values are in each of those bins or ranges. Think of a bin as kind of like a trash bin. So in this trash bin, we dropped 18 to 20. So we dropped 3 data values into that bin. 21 to 23, we had 4 data values that fell into or went into that bin. It says to label the third column frequency, which we already did, and then what number's in the first entry. That was 3 because there were 3 in that first range. Write a sentence that explains what this number means. We'll do that in a second, and complete the frequency column, which we did. Then check the total of your frequency column equals the total number of data values. So if we were to add this up, this should total how many we had to start with. So there'd be 7, 21, 34, 35, 36, 46, 47, 48, 49, 50, 51, 52. So I've gone back and I've double checked, and in our original data there was only 51, and I found the error. The error is I have somehow gotten an extra data value in this bin. So this is one way that you can catch mistakes, which that was completely unintentional, but I did make a mistake here, so we'll fix it. So I've gone back, and there were actually only 3 in the 21 to 23 category, so I extra counted. I counted one of them extra when I was going through. So we'll fix that. This was only 3. So it should total 51 because there's only 51 original data values. So now it says to write a sentence that explains what this number means in context, this 3. So in context, what that means is there were 3 vehicles, or 3 mini compact vehicles in 2013 with miles per gallon of 18 to 20. So again, we want to use our good writing skills, make sure we mention the year and what we're talking about. We're talking about mini compact vehicles. We're talking about their miles per gallon and so on. We don't want to just say there were 3 in that first range, or there were 3 that are 18 to 20, something like that. We want to give some more specifics than that. So for number 6, it says return to question 1. Does the frequency column help you form a better understanding of the gas mileage? So if we look at this, rather than looking at that original table of data that they gave us, or the list of data that they gave us, it definitely helps us see where things are heavy and where there's less. So there's a lot of the vehicles that are from 14, 13, and 13 from this 24 to 35 range. For some reason there's a little gap here that's kind of unusual. Interesting to note that there were 14 from 24 to 26, 13 from 27 to 29, but interestingly enough, there's only 2 that are 30 to 32. But then we go back up to there being 13 from 33 to 35. So for some reason there was this little gap here. And then beyond, 36 to 38 or 23 or less was much less. So most of the vehicles had from 24 to 35 miles per gallon. So it does help you form a better understanding because it groups the data together and gets it organized for you to look at. Okay, so again, I've got question 7 and 8 here. It says relative frequency. This is the thing that we were getting at in this section. Remember, this was our final goal, was to understand relative frequency. Says it's the percentage of all the data values in a particular bin. Sometimes it's a percentage, and sometimes they list it as a decimal. In this material that we have, they usually list it as a percentage. So the answer to question 5, part A, represents what percent of all the data values, round to the nearest tenth. And it says here that we're supposed to label the fourth column. So I'm going to actually do this, and I'll kind of come back to these questions. So we're going to go down here, and we're going to label this last column as relative frequency instead of just frequency. So frequency means exactly how many are there, whereas relative frequency is going to tell us in comparison to the whole. So relative frequency. So when we're looking at this, instead of just saying that there's 3 that are in that category, we can consider that to be 3 out of the total of 51. Now if we divide that, 3 divided by 51 comes out to be, as a decimal, about 0.058. I think it said to round it to the nearest tenth of a percent, so that would be to this spot. So if I shifted the decimal over 2 spots and then I went 1 past that, that'd be 0.0588. So this 8, since it's followed by another 8, would round up to 9. So 0.059 is how we would write this. So again, this is approximately 0.059, which then in our relative frequency we'll write as 5.9%. Nice thing is we have 3 listed 3 times, so we can use that in the other ones. So this would be 5.9%, and this one would also be 5.9%. Okay, so if we continue that for the rest of the data, we have a column that has 14 in it, so 14 out of 51. If we divide that, is 14 out of 51 is 0.2745. So since I'm rounding to this spot right here, because it wants a percentage, then 1 decimal past that, this 4 is going to round up to 5 because it's followed by a 5. Anything past that that's 5 or bigger, I'm going to round that up. So 0.275 will be our decimal for this. 0.275, and if I shift that and make it a percentage, that's 27.5%. So again, however you want to do that, you can think of it as shifting the decimal 2 places, or you can think of it as multiplying by 100. Either one will get you the percentage. We have 2 data values that are 13 out of 51. So 13 out of 51 would be 0.255. Again, that 4 is going to round up to 5 because of the 9 following it. Sorry, I forgot what the number was already. So this is 25.5%. And this would also be 25.5% since it's also 13. And then the last one that we have to do is 2 out of 51. Now that should be less than 5.9% because we know 3 out of 51 was 5.9%. So 2 out of 51 is 0.039. And I'm going to leave that a 9 because it's followed by a 2. So we don't round that 9 up. So 0.039. And so this is about 3.9%. So now what does that mean? It says to write a sentence for that. So write your answer to part A in sentence form. So hopefully I'm remembering this correctly. So 7B, we would say 5.9% of the mini compacts from 2013 have miles per gallon of 18 to 20. So we're just saying in comparison to the whole, rather than just saying there's 3, somebody could say, well, that's nice to know that there's 3, but how many are there total? Is that a lot? Is that a little? So if you just said that 3 of the mini compacts have a mile per gallon, is that 3 out of 20, 3 out of 100? Now we know when we write it as a percentage that it's, you know, close to 6%. It gives us a little bit better idea how it compares to the total. So then the last 2 questions here say, what should be the total of the relative frequency column, and explain that answer with a complete sentence. So I'm going to say the sentence. I'm not going to write it down. But the total of these should be 100%. And the reason it should be 100% is this is all the data. Well, if we have all the data, it should be 100% of the data. The literal meaning of 100% is all of the whole. So if we have 100%, that would be 100 out of 100 of the data, then it should add up to 100%. Now, this may not add up to be exactly 100% because we had to round those. So just be aware of that if you're checking this. If you get 99.9 or 100.1, it doesn't necessarily mean you did anything wrong. It may be because of the rounding. None of these came out to be exact percentages. We had to round them, so your total might be a little bit off. And then our question for number 8 says to refer back to question 6 about the benefits to computing frequency. Does the relative frequency table help you form a better understanding? So again, it does, you know, we can see that the higher categories were the 27.5 and the 25.5, that they were much bigger than these other categories, and gives us just a different understanding, a little bit maybe better understanding to have both of them. Okay, so then our last bit of questions on this section for 5B talks about the fact that there's no specific rule for bin size or number of bins. But if you choose your bin size differently, it may make the data look different. So I actually have read where it says that your bins, you should have, as far as your number of bins, from 5 to 20, no less than 5 and no more than 20. So we've got a table here, where a frequency table, where they only have 3 bins. Whereas before we had, I can't even remember how many there were, just a second. We had 2, 3, 4, 5, 6. We had 7 bins. So the 7 was between the range that I've seen recommended, whereas here we have it kind of small. What happens is the data gets kind of clustered up and you can't see some of the patterns when that happens. So let's see what happens to this. I'm going to go ahead and tally these while not recording so that you don't have to watch it. But what I'm going to do is I'm going to again go through the data and mark a tally for each one. So I'm going to mark 19, 19, 34. So here's my 19, my 19, my 34, and I'll pause and finish this up and come back. So now I've finished this up, and I'm going to go ahead and fill in the frequencies. You'll notice I had so many in this bin, because this bin is so large, 25 to 34. Remember, we had most of our data, I think, was like 24 to 28, is what we said before. And so here we have, I'm going to do a different color so it doesn't get mixed up. So here I had a frequency of 11. Here I had a frequency of 10, 20, 32. Here I had a frequency of 8. So again, that adds up to 51, which is what we wanted. And if I go to calculate the relative frequency, again, this is so clustered up, we know that there are 32 that are from 25 to 34, but we don't see the same type of patterns that we saw before. If we did the relative frequencies, you would still see it the same way, or do it the same way. So it would be 11 out of 51, which is 0.216. If we round correctly. So this is about 21.6%. Then we'd have 32 out of 51, which is going to be well over half. And it definitely gives us a different view of the data. We don't get the same information that we had from before. You know, some may prefer it. I kind of prefer for it to be a little bit more spread out. We're going to say 0.627 because there's a 4 after the 7, so we're not going to round that up. So about 62.7% of the data are here. Well over half is between 25 or from 25 to 34. And then we have 8 out of 51, which is 0.1568. So I'm going to round this to 0.157. and this is about 15.7% of the data. Again, when I add these up, it should total 51 because that's how many total data values I have. And when I add this up, it should total 100%. Occasionally that'll come out again like 99.9% or 100.1%, depending on how the rounding goes. I think this one comes out to be exactly 100%. So does this new relative frequency table help you form a better understanding? I would say a different understanding. I don't know if it's a better understanding, but it's definitely different. If this was all we had, we didn't have the other one to look at, we would definitely know it was more clustered here, but we wouldn't know the very small number that are safe. I think we had 19 to 21 was our first, 18 to 20. So this one goes all the way down to 15. We don't even realize that, hey, there's not even any that are 15, 16, or 17 when we look at this table if we didn't have this original data. So this is kind of a little misleading, and also that we didn't have any that were over 38. So this makes it seem like there's, you know, several that are in this category, but it doesn't. We don't realize that there's not even any that are 39, 40, or so on. So it kind of clusters the data together and gives us a little bit less of some specifics of the data.